Algebra 1 skills number 1, square root operations. So we're going to start with a 2-column slide here to show you 2 different ways to simplify the square root of 20. When we simplify a square root, that doesn't mean type it into the calculator and write down the decimal. It wants you to write it by removing all of the perfect squares within the number. So example here, square root of 20. I'm going to show you first the less common way that some people may like better, and that's to make a factor tree out of 20. 2 times 2 times 5 is 20 if you broke it down into a factor tree like you've done in previous courses. And notice the red here on the 2. If you get a pair of numbers, that 2 goes to the outside. So it's 2 times the square root of 5. The 5, which did not have a pair, has to stay on the inside. So 2 on the inside makes 1 on the outside. And that seems real simple because 20 is such a small number. It's an easy factor tree. So if you have one that's an easy factor tree, this may be the preferred method. But most of this slideshow, mostly in class, I'm going to show the second method. And that's where we think of the largest perfect square that goes into 20. And it's best if you get the largest perfect square. And we'll see an example if you don't later. But perfect squares are numbers such as 4, which you see here. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And most people have the first several of those memorized. And you're going to want to ask yourself, what perfect square goes into 20? Well, 4 does. And 4 goes in there 5 times. So we can break down the square root of 20 like this. 2 different square roots where they're multiplied. That would be equivalent. And the square root of 4 is 2. Okay, so it's a just as easy method that I think as this gets bigger, this right-hand method becomes more efficient. Okay, so we're going to see another example here. So now 72 is a little bigger, so I'm not going to show the factor tree method because you just end up with a lot of numbers. But I am going to show you what happens if you don't take out the largest perfect square first. Now we just saw where 4 goes into 20. Well, 4 also goes into 72 18 times. The problem here, though, is, and that, 2 square root of 18, so far so good. And notice, by the way, I didn't say this last time, that square root is gone now that we took it. So there's not the square root here. But 18 also has a perfect square inside of it. 4 does not go into 18, but 9, which is 3 times 3, does. So we need to continue here. So notice, again, the color coding, 9 times 2 is 18. The square root of 9 is 3. And as we're going to see later, we're getting ahead a little bit here, if you have 2 outside numbers, you can work with those, but don't mix an outside number and an inside number. So 2 times 3 is 6. So we get 6 root 2. So we end up having to do that twice. Now what would have been more efficient is to realize that 4 is not the biggest perfect square that goes into 72. There's actually another one. You might want to sit and think, what other perfect square, numbers like 2 times 2, 3 times 3, 4 times 4, what other perfect square goes into 72? Well, 36 does. 36, which is 6 times 6, goes into 72 2 times. And when you take the square root of 36, you more efficiently get that same answer. See that 6 root 2 and 6 root 2 here? So if you're able to find the biggest perfect square first, it's more efficient. But if you just find a perfect square, you're still okay as long as you make sure that when you're done, there's not a perfect square left in this. Clearly, no perfect square goes into 2. So 6 root 2 is correct there. A third example, what happens when we multiply? We already kind of did this on the previous example on the left-hand side. But as I said here, outside times outside and inside times inside. So we can work with the outside numbers separately than the inside numbers. So if I do that, 2 times 3 is 6, and 6 times 10 is 60. And just like before, make sure there's no perfect squares in here. Well, perfect squares, you've got 4, you've got 9, you've got 16, you've got 25. Well, 4 does go into 60. It goes in there 15 times. So we can break that down. Notice that this 6, which was already out there, just stays out there. The square root of 4 is 2. And again, if you have 2 outside numbers, you can go ahead and get those together. So 12 root 15 in that example. When we add square roots, you must have the same number under the square root. This is a fancy way of saying this is the radicand, which is not an incredibly important vocabulary term right now. But we need to have the same number on the inside, or the same radicand, to be able to add. And if you do have the same radicand, then you just add the outside. So it's 9 root 7. That's your answer. So let me stress that this was not necessary when you multiply. If this was a times, you just say 6 times 3, 7 times 7. You don't worry about if they're the same or not. But when you add or subtract, they do have to be the same. Okay, so what if they're not the same? We're subtracting, which is essentially the same thing as adding the net opposite. So here we cannot say square root of 21. That doesn't work here. So I want to emphasize that. Only if they're the same. It's kind of like when you're adding fractions. Only when you have the same denominator there can you go on. Well, here, only when you have the same number under the square root can you go on. All right, so what we've got to do then is, like before, break down the 28, 4 and 7. 4's worked a lot here for us. It's not always going to be the number, but 4 is a common one. Square root of 4 is 2, okay? And notice the 7 there illustrates that we're the same, so this is good. 2 times 2 is 4, and now finally we've got the 7's the same, so we can subtract the outsides, negative 4 root 7. So square root operations.